Hello, and welcome to the eTech podcast with me, your host, Ryan Morn. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. So we've got a few things going on with today's podcast. First of all, as you probably noticed, if you are watching this on YouTube, instead of just being an audio podcast, we've got video, so you can see me. I know I've kind of got a face for radio, but we're going to do this as a video. So if you're not on YouTube and you want to see the video, head across to YouTube because it will be over there. So then the podcast today is actually an interview with a really great guy, Dr. Ben Todd. He runs a business called Arcola Energy, and they're specialists in systems integration and development of fuel cell powertrains. So we got down and talked to Ben about all things fuel cell and where they come in the market and the kind of things that Arcola are up to. And we hope you're going to find it really interesting to maybe get a bit of an insight about what's happening right now in the world of fuel cells. So without further ado, we'll get on with the interview with Ben. Okay, so thanks for agreeing to do this today, Ben. Really pleased to have you here. Do you want to just tell us who you are and a bit about Arcola Energy?
Yeah, so I'm Ben. I'm the founder CEO of Arcola Energy. So Arcola was created about 10 years ago, really to kind of fill the gap between fuel cell and actually other low carbon technologies and the kind of need for those technologies in the market. So I've been in fuel cells now about 20 years. So I was doing my PhD and then kind of a bit of consulting after that. And what I was seeing all the time was these really nice technologies, really serious need, obviously climate change and air quality. But the technologies were just never making it to market. It's that classic thing with engineers. I'm going to build this brilliant thing and people will use it. Yeah. They don't.
Okay, yeah.
And so Arcola Energy really in a way was created almost out of frustration. It was just going, okay, well there's this good tech, there's this serious need. Yeah. How about if I set up a company it's not very glamorous, it's not based on patents, it's not about inventing amazing things, it's not designed to make a load of investors really, really rich. It's just about going, well, what's needed? What do we need to do? Whatever it takes to put fuel cells and hydrogen into kind of sensible, real world, make the world better type applications, that's what we'll do.
Right, okay. So Arcola does fuel cell applications. You mentioned you did a PhD, was that was to do with fuel cells?
That was that was in fuel cells. So that was quite accidental. I mean,
okay.
Cards on the table. The plan was not especially to go into fuel cells. So as I was brought up in Liverpool with this kind of, I guess I would call them crudely, my nice hippie family.
Yeah, okay.
That's how I kind of brought up. You need to make the world better. Yeah. That's what maketh man, if you like.
Yes.
Or woman. So I was an engineer. I've always kind of fixed things and broken things. So when you put those two things together, well, you've got to do something around sustainability. And so I was working on power stations, so natural gas combined cycle power stations. How do you make conventional power stations better? Yeah. And through that, I got really into thermodynamics. And the kind of thermodynamics is where kind of humanity reaches the other, God or the universe, whatever you want to call it.
Quite spiritual, okay, yeah.
Yeah, I mean, well, where do you go? What's the best that you can do?
Yeah.
If you look at the world around you, as an engineer, you want to understand, you're always interested in limits. How good can this be? Yeah. How rubbish is that? Okay. And so thermodynamics sets this kind of, I guess, scientific framework for kind of how good you are and how hard you should be trying. And fuel cells fall out of that. So thermodynamically, in theory, fuel cells can give you 100% efficiency.
Okay, yeah.
Based on the usual measures we used, so
right.
Kind of LHV efficiency. And so obviously as a kind of young engineer, you're like, wow, this is amazing.
It's cool, yeah.
Now, of course, that's in theory.
Better than your coal-burning fossil power station at 40% or something.
Exactly. Yeah. So if you're looking at that kind of thing, so then, in thermodynamics, the Carnot efficiency, which is just about, the difference between the highest temperature of combustion and the lowest temperature of, dumping heat into a river or something. And so fuel cells are not limited by Carnot. Yeah. And so I was like, wow, this is amazing. Fuel cells must be great. So I got kind of seduced by that idea of what they could be. Now, of course, in reality, there's all kinds of limitations.
Yeah.
So you've got kinetics and you've got this, that, and the other. So you don't get 100% efficiency. And anyone that tells you do, they don't know what they're talking about. But what you do have is the potential for very high efficiency, for very low emissions, and this kind of flexibility around fuel. So typically we talk about hydrogen fuel cells.
Yeah.
The type of fuel cells, actually, I was working on high temperature fuel cells which would run on natural gas. So the thing I was most interested in is, can you take the kind of waste gas from, say, a sewage treatment plant, put that into a fuel cell, and then you get electricity and actually also get heat. So these high temperature fuel cells give you a really good high quality waste heat. And then if you make it big enough, you can then take that waste heat and you put it into a gas turbine, and then you get some more electricity out the gas turbine. So a gas turbine's like an aeroplane engine. So my PhD is sponsored by Rolls-Royce in that area. And then actually you take the waste heat from the gas turbine and you put it into a steam turbine. So, the old kind of Watts engine. So you get kind of 3 bites of the cherry. So you get electricity out the fuel cell, electricity out the gas turbine, electricity out the steam turbine, and you made it all basically from poo.
Right. Okay. What's not to love about that?
Exactly. Yeah. It's like the kind of young engineer's dream. So that's what I was working in. And the challenge with all of that is, it's brilliant, but actually the material science that you need to make those fuel cells happen, and the kind of general engineering, production engineering needed, just meant it was really slow.
Right. Okay. And because fuel cells. You said you've been, was it 20 years you just said?
Best part of it.
So 20 years is a long time.
Thanks.
Probably feels like it sometimes as well, and neither of us are as young as we used to be.
Indeed.
But fuel cells have been around for a long time, and they've been one of these things where it's always kind of been sort of 10 years away from being commercial.
For the past 100 years is the joke.
Yeah. So, and in the past there was definitely, like I could see, all right, there's a problem here to solve in terms of we don't have battery storage and things that can do what it needs to do, but batteries seem to be improving all the time. And I have heard some interesting things fuel cell related in the last sort of 6 months, but it feels like in a lot of cases a fuel cell sort of fixing a problem that doesn't exist anymore, or do you still see there being a big opportunity for fuel cells?
So I think there's a couple of load of good stuff in there. So there's, let's say the first point, probably from my personal perspective. So when I was doing my PhD, I had a website, Fuel Cell Knowledge, which was effectively, again, that kind of naive academic thing of just sharing the things I found, the things I'd learned about fuel cells. Yeah. And after a while, I got kind of frustrated with this. At that time, it was all about hydrogen. The hype was always around hydrogen. And I actually set up another website called Electrochemical Economy. So there's this hydrogen economy, and I was the electrochemical economy is the bit that I really care about. So whether it's a fuel cell or a battery, which are basically sister technologies, what I care about is basically not burning things.
Yes.
So in general, burning things is not the best idea.
Right, yeah.
Thermodynamically, it's a disaster. You create loads of entropy.
Yeah.
So let's say I think the key to me is basically electrochemistry and no emissions. I'm not a kind of fuel cell maniac. In terms of that question of, is it batteries or is it fuel cells, I think the answer is very much still both.
Right.
If you can do it with a battery, do it with a battery.
Right.
Because now it's easier, it's cheaper, it's quicker. Batteries have got to volume, or the beginning of volume, and have come down the cost curves ahead of fuel cells. If you look at the kind of cost and volume projections on fuel cells, they're basically following batteries.
Okay.
So they are going in the right direction. Costs are coming down, volumes are going up.
Yeah.
So I tend to think of it, in the very beginning of my career, it was when solar was still, what's solar? What's the point of that? Or wind? Yeah. And we've seen all of them now move into kind of reality.
Yeah.
And I think, you can say the same with battery. I mean, I've heard you say, it wasn't that long ago that people thought you were nuts for doing electrification.
Yes.
And now it's all about that.
Yeah.
And I think so fuel cells are effectively getting to that point.
And is that for hydrogen or is it for other?
So it generally is hydrogen.
Okay.
Which is
lower temperature.
So it's lower temperature, and the really interesting thing is, so when you go back 5-10 years, we were looking for applications that didn't use much hydrogen,
right?
Because hydrogen is expensive and inconvenient. So you'd say, so people start looking at mobile phones, laptops, telecom backup. So, watts to hundreds of watts to kilowatts. And what's happened in that time is actually batteries have just got better and better and better.
Yeah.
And if you want watts, in most cases, the battery is the perfect thing. You want to charge your mobile phone, batteries are brilliant.
Yeah.
there are some low power applications if you want to run for a really long time where batteries become impractical.
Yeah.
But generally, if you go to the larger scale and you need to run for a long time, that's where the fuel cell starts to make sense. And actually, when you get to really big scale, so utility scale, the kind of thing that we wouldn't think about particularly 10 years ago, it was the kind of pipe dream, Hytopia, I call it.
Hytopia.
Yeah.
That's cool. I'm going to use that. Hytopia, yeah.
It's a one you get... Yeah, people have been talking about it since the oil crisis. And, there's this great dream, but actually what we're starting to see is actually that is beginning to be the bit that makes sense.
Yeah.
So anyone that's saying that, well, the fuel cells are rubbish, batteries do everything, are probably looking at applications where fuel cells really don't make sense.
Right.
And
so people have lower power.
People have spent a lot of time trying to peddle fuel cells in the wrong application.
Right.
So it's petrol, diesel, CNG, LNG.
There's a market for all of them, right?
There's a market for all of them. They're not interchangeable. You put the wrong one in the market and it's just a daft idea. Like, why are you doing that? It makes no sense.
Yeah.
So I think there is a kind of legacy of the kind of hype around hydrogen. It really attracts people that love hype. That idea, the most abundant element in the universe, it's everywhere. You can make cars run on water. All the kind of stuff that drives me nuts because you don't make cars run on water, obviously.
Yeah.
The hydrogen may come from water through electrolysis. So it kind of attracts that hype, and then you get people pushing products that make no sense. Yeah. So I think it's totally understandable. You've got that sense it doesn't make sense.
And you mentioned their electrolysis, and one of the things that people are often quite critical on fuel cells, and I know you've got some interesting views on this, is the and you mentioned earlier about the 100% efficiency potential, so no entropy, but you've got with a fuel cell system, you've got a sort of energy input cost to generate your, let's say, fuel, so the storage medium, hydrogen typically, then you've got the sort of fuel cell operation, and people look at that and say, well, actually it's really expensive to create the fuel in this case.
Yep.
And that makes the fuel cells not viable in terms of the so forgetting the technology challenges and all that sort of stuff, but just the simple fact that you've got all these extra conversion losses. So what's your take on that? Because that's quite a big part of the puzzle, isn't it, getting that right?
Yeah, so I think it's critical. I think the only way to look at that is in a kind of sensible, kind of grown-up way. And so the first answer is, if you can use electricity directly in the electrical form, avoid conversion steps at all, any way you can.
Yeah.
And so we use hydrogen where there's effectively a justification. What's the benefit? So if I say to you, right, well, I want to store energy for 3 months to deal with seasonal swings, energy supply and demand. Right, let's go and use a battery. Well, you quickly realise you need an awful lot of batteries and it quickly becomes impractical.
Yeah.
Look at fuel cells and hydrogen storage, it may well be totally practical. So at that point you say, okay, well, look, I've lost 30-40% of the energy that I put in, but I get the energy back when I want it, and the economics work.
Yeah.
And so it's always that trade-off. I mean, if we look at electricity cost, if you take electricity directly out of the mains, it's cheap.
Yeah.
That's a reference cost. If you take electricity out of an AA battery, the cost difference between mains electricity and AA battery is orders of magnitude.
Yeah.
But the AA battery gives you practicality.
Yeah.
And so in a way, it's almost the same on an efficiency basis with hydrogen. If you can do it directly, do it. Yeah. But there's going to be loads of applications where you simply can't.
And do you think, so one of the scenarios that I've often talk about, and I know you've got a really interesting project that's kind of connected to this, so is like if you've got a fleet of electric trucks, you want to charge one truck, that's fine. You want to charge 200 trucks, all of a sudden you've got a massive infrastructure problem, and you've actually got to make a huge investment in terms of upgrading the electrical infrastructure. There's an embodied cost in that. So yeah, the electrical efficiency might be great, but you've had to spend a huge amount of capex to upgrade your infrastructure, which has got an embodied carbon cost in it as well. So fuel cells kind of come into play in that sort of application. And I know one of in fact I saw you talking about it just yesterday, is your rail project, and part of the argument there is not investing in the capex of electrifying lines and having fuel cell powered rolling stock instead. So do you think the economics of that are understood?
Yeah, so that's within the kind of rail sector, there's obviously some lines that have been electrified and there's a lot that haven't, so they're running diesel locomotives, and increasingly from a local air quality. So if you were to go into Birmingham New Street Station, it's pretty smelly down there because of diesel locomotives. And then if you more broadly, there's a push towards electrification. As you said, the cost of putting in electric infrastructure, whether overheads or third rail, is really high. And there are plenty of applications where it's very likely that if you could electrify the train rather than essentially the track, you end up with it's much quicker, which actually is really important, and probably also cheaper. So there's a push obviously towards battery trains, which for very short stop-start runs probably works fine.
Right.
But the range, it's a kind of perfect example really of where batteries are brilliant for the really short stuff. They just don't give you the duration for the long run.
Right.
So we've got a project with a company called Viva Rail, who are developing trains for branch lines, so they're kind of shorter lines. So it's not doing a long haul, kind of London, Edinburgh. It's doing branch lines in regions. And these are very much, in a sense, you could almost think of them as the kind of buses of trains.
Okay.
So if you think of buses and coaches, coaches do long hauls up motorways, buses do city journeys.
Yeah.
And then, so in that branch line operation, stop-start, so you can recover quite a lot from regen. So electrification gives you a really nice benefit.
Yeah.
So power batteries to recover the energy and to give you nice acceleration.
Yeah.
And then for range, you essentially then hybridize with a fuel cell.
Right.
So
Okay.
it's a kind of classic application to us. Batteries doing what batteries do really well, which is power.
Yeah.
Fuel cells and hydrogen doing what hydrogen and fuel cells do really well, which is energy. Bring them together, and that's in a way that's the kind of core of our approach to things.
So on an electric train, fundamentally it's an electrified train. So you've got electric motors driving it. You still have a battery pack, but a smaller one, I guess.
Exactly.
And then you have a fuel cell as your kind of primary energy generator.
So you can think of it as the primary energy generator, or very often people talk about it as a range extender.
Right.
So which end you come at it from.
Yeah.
If you like, from a pure fuel cell end, you could say, okay, I've got this fuel cell, but I need some help with the power spikes.
Yeah.
So I could put in super caps, which would be great at whacking out loads of power, sucking up.
Yeah.
But actually, you may get to the point where super caps can't quite do it, and then you move to a power battery.
Okay.
And obviously, the other way of looking at it is, I've got this really brilliant fuel cell, I've got this really brilliant battery train, but I can't quite get the range. Wouldn't it be great if I had a range extender?
Right.
So then you get into your classic hybrid.
Yeah.
So it could be the Toyota Prius type approach, which is battery and a petrol engine. And we effectively give you the alternative, which is the fuel cell engine.
And in a train, is there any special requirements for the fuel cell system? I imagine it's quite a big fuel cell in a train.
Yeah. So for the branch line trains, they're not. There's that funny thing. We always have this perception that trains are kind of huge. You think of the Flying Scotsman of old. The branch line trains are actually not that big. So they kind of cross over from kind of bus into train. There is a step, but it's not massive.
Right.
So the fuel cells that go into a train. For a smaller train, very much depends on the route, but you might be looking at kind of 100 kilowatts.
Oh, right, okay.
Which is really not massive because it's that stop-start.
Okay.
And the branch lines are not particularly high speed. Trains, of course, the whole point of trains is they have nice low rolling resistance.
Yeah.
And a double-decker bus is like pushing a sail through the wind.
Yeah.
A train is obviously
quite slippery.
Slippery.
On the wheels of steel and all that. Yeah. And is it using... presumably it's conventional hydrogen system, pressurized gas storage?
Compressed gas. So within hydrogen storage, there's a whole load of different approaches to hydrogen. So if we say, okay, we want to use this fuel cell, we want to get this range extension, next question, how do I store the hydrogen?
Yeah.
So compressed hydrogen is the first answer. So you're using tanks, same as you might do with CNG.
Yeah.
Or many of the same manufacturers, in fact, branching into hydrogen.
Yeah.
And you'd compress on heavy vehicles. Typically, it's 350 bar, which is roughly double what you get in an industrial cylinder.
Yeah.
So steel cylinders knocking around everywhere, hospitals, workshops, factories, about 170 bar, say. So these 350 bar tanks, they are higher, but they're not massively high, and they're well within kind of comfortable ranges.
Yeah. So
they're typically chosen. That's quite straightforward. For passenger car, then you might jump up to 700 bar, which really is quite high pressure.
Yeah.
So it's out of the...
And that's to get extra energy storage, basically.
You get extra energy storage. Annoyingly, hydrogen's not an ideal gas. So when you double the pressure, you don't actually double the storage, but you get probably 2/3 more.
Right.
So there's been lots of thinking over the years. You can imagine what are the optimum pressures. So how much energy do you lose in compressing the gas versus how much can you squeeze in? So there's always an option we think of 350 is the starting point. It's lower cost, easier. If you suddenly realise, if I could just get that little bit more, then we might consider going to 700. So that's your compressed hydrogen. From there, you can then move into metal hydrides, which is probably, I guess, the chemical equivalent of compression. So it would be a low-pressure cylinder with a hydride in there that would absorb hydrogen onto the surface for a metal matrix. So the benefit of that is it's low pressure. It's quite heavy, which doesn't matter so much in a train.
Yeah.
And there's a lot of kind of advanced hydrides coming forward where you might get to the similar kind of weight percentage. So we typically think, well, there's two approaches to how good's a storage mechanism. It's the kind of gravimetric, so weight efficiency, and your volumetric.
Yeah.
So hydrides are getting quite up there in terms of weight. And then you can then start to make kind of the bigger steps then of saying, well, actually hydrogen's an element we combine with others. So kind of chemical storage, or even, in fact, generation. So you can generate hydrogen on the fly from chemical hydrides and so on. But I think you'll find, at least in the short term, almost everything's going to be compressed hydrogen.
Right. And on a rail system, presumably you've got to put in some sort of hydrogen generation refueling plant. Are you typically doing electrolyzers there, or is it supplied in tanks, tanked hydrogen?
Yeah, so you've got... So your objective with your train is, of course, to refuel your train as quickly as possible, or any vehicle. So typically with a car, a bus, truck, train, very likely you're going to be doing it with a refueling nozzle, as you'd be used to with a liquid fuel or indeed gaseous fuel, CNG. So that's your refueling. So there's effectively... there's a compressor. You may have some high pressure storage to allow you to kind of fill faster. Yeah. Or you can just compress directly into the vehicle. So there's a kind of cost optimization to be done there. Yeah. Sitting behind that then, if you like, is the source of hydrogen. And then you have a kind of plethora of options. So I think if you do the sums at the moment, there's enough hydrogen being generated to drive every car in the world about 5,000 kilometres per year.
Right, okay.
There's quite an extraordinary amount of hydrogen manufactured right now.
Yeah. Used in other
industrial processes.
Right.
So oil refineries, steelworks, ceramics. So you use it.
Making margarine.
Yes. Electronics.
For that.
So I mean, you use it in furnaces to get that extra bump of temperature.
Yeah.
Yeah. So a lot of places where you need that extra. So there's a massive amount of hydrogen. Almost all of that then is made from steam methane reforming.
Okay.
So that's basically combining in the appropriate catalyst and temperature, steam and natural gas.
Yeah.
So if you've got a good source of natural gas and steam reforming plant, of course you can make hydrogen.
What do you do about, because presumably that reaction there releases carbon dioxide?
Exactly.
And you can catch that somehow?
So, you've got two choices. So you're starting with natural gas. So fundamentally you're bringing in a fossil fuel typically. Obviously you could also use biogas.
Syngas,
some kind of syngas, so you're producing CO2. The CO2 is pure. So you have the option to pull off that CO2 and sequester. But obviously at the moment in general it's vented. So you're still producing CO2. So if you start with natural gas as a fuel, you will release CO2.
Right.
So your benefit, then you may have an efficiency benefit, but you also have a local air pollution benefit. So
right.
In some sense, in that case, you may simply be moving pollution around.
Yeah.
So then the kind of holy grail, back to that Hytopia idea, is if you could do electrolysis of water using renewable electricity,
right,
then you're fully renewable. And you have that added benefit we talked about of hydrogen for storage, is that you can deal with the intermittency of renewables by bringing in large grid-scale, utility-scale electrolyzers to help you balance supply.
Which was actually, literally my next question was going to be about, we see a lot of people talking about hydrogen mixed with renewables, and I'm just wondering how that kind of, how it fits in the mix. So when you see people talking about using hydrogen to balance out renewables, what do they actually mean by that?
So within renewables, people talk a lot about back in the strained renewables. You've got a wind turbine that's generating, and effectively they can't sell the power because the grid can't take it.
Yeah.
And it says, we could make that into hydrogen. So in the short term, you have to be careful about people saying, look, we had all this constrained wind for a couple of minutes. Let's build an electrolyzer.
Right.
Your utilisation of your electrolyzer then is not going to be very good. So the business case doesn't work out. Right. So if you just take the kind of immediate glitter, this is a brilliant idea, then quite quickly it'll fall down.
Right.
And there's a danger, as always, very often there is in the hydrogen industry, is people make a big fuss about this one potential, people realise it doesn't make sense, and then baby in the bathwater.
Wow.
As you move to a greater penetration of renewables, you're not talking about one particular cable, one particular wind turbine. You're talking about generally having greater demand and supply side balancing.
Yeah. So this is so basically, in the past you might have done a pump storage scheme.
Yes.
Now you're going to do a hydrogen storage scheme instead of pump storage, because pump storage is basically impossible to get planning permission for and stuff these days.
Yeah, there's certain places where you can do pump storage, and there's not that many others. And with the electrolysis, you would do it. You can either do demand or it's always going to be demand, but you can turn up or you can turn down.
Yeah,
so it's a tunable load.
Yeah.
And if you like from there, what you're trying to do then is displace all of the kind of diesel gensets running in fields around the country, balancing the grid.
Yeah.
So it's an area that I think will become increasingly interesting. There was a report just out today, I think, from International Energy Agency, looking at this, a kind of longer view. How do you do really deep decarbonisation? And increasingly hydrogen features in that.
Right.
And so that the interesting challenge for us all now is saying, okay, there's these things we can do today, buses, trains. There's this thing we need to do in the future where we've got massive renewables penetration, and we need to balance those renewables. Or those looking at nuclear are saying, well, nuclear power stations don't like being turned up and down either. No. So you could use hydrogen to balance renewables. But in the middle, you've got this, as always, this kind of valley of death, where you can do projects, but do those projects in themselves directly make financial sense?
Well, it's interesting seeing you guys get traction on the rail side. And the economics there just seem to be, it's almost like a no-brainer, where you have a choice. We could spend 3 billion electrifying this branch line network, or we can spend 2 billion doing the hydrogen, because the numbers are quite stark that I've seen. It's like a huge saving to not electrify the line and electrify the trains and go for hydrogen instead.
Yeah, no, I mean, it is there are these business models emerging that there is actually a business case. Yeah, which those of us who've been in fuel cells for a long time are like, wow, an actual real business case. It's really nice. You're trying to push new tech forward. Yeah. You're always competing with an incumbent that's had 100 years of cost down. Yeah. They're very much emerging, and that's key really, is get those projects done. So doing a whole load of trains is not going to suddenly change the entire national grid, but it's giving us traction in the market. We're getting volumes out, we're getting out of the hundreds of units into the thousands and the tens of thousands, and it's very simple, economies of scale and cost reduction.
And the rail market's sort of notorious, actually rail and the bus market, notorious for not moving very quickly. Are you starting to see that change, or is it still I think so. I'm no rail industry expert, so Richard, my colleague, has worked in innovation in rail for a long time, and there's a certain frustration within rail. The assets last for a long time. You think about railway people thinking 100-year time horizons. So there is that challenge of how you do innovation, but there's this really strong push, I think, now of people. Very much, I guess the thing we see in other vehicles where people are saying, "Oh, am I going to be stuck with diesel assets that I can't do anything with?" Yeah. In 20 years' time, who wants a diesel locomotive? Yeah. And if you're a rolling stock company and you've got trains that have got a 20, 30, 40, 50-year economic life, you've got to be thinking really quite carefully about it. Yeah, what do you do with them? Yeah. So, the interesting for us, Viva Rail in particular, so that there's 3 electric hydrogen train projects in the UK. So Viva Rail that we're working with, they're actually their model at the moment is refurbishing. So they're taking existing rolling stock and repurposing it. It's hard. I guess in rail it's maybe slightly different because of the length of the asset, and they do those refurb points anyway. But we always get people wanting to talk about doing like sort of refurb programs on vans, and the economics on small stuff just doesn't work.
No, it doesn't. I think trains. I'm relatively new into it, but from what I can see, it really does work. Trains get refurbed, and they last a really long time. Yeah.
And East Coast Main Line this week on a train that was probably 40 odd years old. Yeah.
And ideally you wouldn't know because it had been refurbed so nicely.
Ideally, yes.
No comment.
I don't think it had been hoovered in 40 years.
No comment. So in terms of getting innovation into rail, so Viva Rail is really interesting. It's set up by Adrian Shooter, who used to run a train line, so ran the franchise, Chiltern Railways franchise. So he's got that knowledge from, how do you run lines? Yeah. Now I'm going to start actually creating rolling stock. Yeah. And as we always find, I guess with any tech, but obviously my experience, fuel cells and hydrogen, you really need to join up the whole piece.
Yeah.
So you bring a new technology to market, you are actually changing the market.
Yeah.
And that to us, why the Viva Rail approach is really interesting.
And those trains that are being repurposed there, they probably were diesel originally, so there's it's a whole new running.
The first trains that Viva Rail are doing are actually I think it was Metropolitan line tube trains.
Oh, right, okay.
It's really quite fascinating. So these are tube trains that got end of life for tube, for whatever reason. Aluminium.
Yeah.
Lightweight.
Yeah.
Very little corrosion issue. Going for a song. If you refit them nicely, nobody knows.
Yeah.
So you end up with quiet, lightweight, so you get good acceleration.
Yeah.
It's a strange thing. It kind of looks like, well, that's kind of a no. As you say, it's a no-brainer.
Recycling, it's the ultimate upcycling.
Yeah.
Never mind your Farrow and Ball paint on your dodgy 1970s wardrobe. It's it's a whole train.
Yeah. And so
slightly more technology. Yeah,
a little bit more tech.
A bit more techy than that. Yeah.
You put the wrong paint on top of an old wardrobe, it doesn't work. You get crazing you didn't want. So I think these are the markets that are starting to move, and the key is, as they start to move, we get experience, we get cost reduction. We had a colleague at an asset finance event yesterday. The point at which kind of asset finance people can say, okay, that's actually now a bankable project.
Yeah.
Suddenly these things start to roll.
Yeah.
Because the early projects, you've got the technology challenge, you've got the kind of bringing the market with you, bringing the partners together, getting the confidence, and then you've got a financing challenge.
Yeah.
So as all of these things start to drop out,
it just gets a bit easier.
Those bigger projects should start to come through.
So then, from a business point of view, you guys must be going gangbusters at the minute. What's happening at a business level with Arcola?
Yeah, we're busy. We're recruiting like crazy, just like Avid.
Yeah.
At the other end of the country, or at the other side of the country now as well. We started it out in London, and we've now I've come home to Liverpool as well. So we've just opened a manufacturing facility in Liverpool. And the approach, again, I suppose, from our initial premise, what do you need to do to make these things actually useful? We've understood that in most of the markets we're looking at, so we're not doing passenger cars.
Right.
So you want a hydrogen passenger car, go talk to Toyota.
Yeah.
High volume, that's our expertise. There's not that much I can add in that area. But we're typically looking at essentially niche vehicles. So buses, even trucks, trains are relative niche. And then within that, then you're looking at particular applications. So it's not just trucks; it's actually refuse collection trucks.
Yeah.
And so you get these really quite niche applications, and there simply isn't the engineering budget appetite. So there's this real need for people to come in with exactly, I guess, an Avid approach. How do you come with a solution?
Yeah.
So we will produce type-approved hydrogen systems and fuel cell systems, and kind of all of the stuff you need to go in between.
Yeah.
So that we can deliver tier one into OEMs. So you can say, okay, look, we're manufacturing refuse collection vehicles, and we'd like a fuel cell refuse collection vehicle. Okay, here you go.
Yeah.
Within a year, you can have one.
Here's a powertrain.
Taking away the risk, appetite is strong.
Good. And so one market that you haven't mentioned, but is often comes up with in connection with fuel cells, is marine.
Yep.
Do you see any interesting things going on there?
Yeah, there's a lot. There's a lot of interest, and marine is actually a good example of. There's the early projects are around, again, if you like, the kind of bus version of marine.
Right.
So these effectively commuter kind of ro-ro ferries.
Yeah.
So there's quite a few projects there's kind of rush on at the moment. I think there's 3 projects across 3 continents, and they're all rushing to be first.
Right.
The one in Scotland's going to win, obviously.
Yeah.
And so that's that bit. And then at the other level, it's the really long, like heavy container ships.
Yeah.
So this massive kind of cross
megawatt power systems.
Again, going back to that IEA report today, they're saying actually these are the places we should be looking. So these ships are typically running from heavily industrialised areas where there is already a whole load of hydrogen production. Yeah. And they're typically linking continents from heavy industrial area to heavy industrial area. Yeah. And I think there's been a lot of noise recently around people just realising how filthy aspects of the shipping industry are.
It's terrible. Yeah,
it's just not regulated at all.
No, they basically run on road tar and spew out all kinds of. Yeah. Never mind the CO2; it's all the other certain
the horrors.
And then the strangest thing is the big solution in the marine industry was exhaust scrubbers.
Yeah.
And that's just like, right, so you've gone from putting this stuff into the sky and it raining back down again, which was bad. So now you're just scrubbing it straight out and putting it straight into the sea. Because that's better. Why? Just kind of filthy, horrible kind of. But so we all depend on it, right? Like actually, without shipping, industry, global commerce, like that is how stuff is moved around. But it's
we're all responsible for it, for the need for it.
Yeah.
But yeah, it's huge. You said, is the rail industry tough to innovate in? I can imagine that the global shipping industry is even tougher. These are massive sums of money, long asset life. But there's quite a lot of energy in that. So we're not looking at that scale. We've got lots of conversations open on the smaller scale.
Smaller stuff, right.
And then the other one we didn't touch on then is the kind of off-highway vehicles.
Right.
So there's a kind of increasing interest. So if you look at cities like London, where they've done a lot of work on road vehicles, so buses and trucks and cars.
Yeah.
If you clean those up, of course, what you then start to see is the other stuff.
Construction sites,
Yeah, so you've got construction sites, whether it's lighting towers, gensets, excavators, and all this kind of associated, so the non-road mobile machinery directive coming through. And so there's a kind of increasing interest there. And as I guess with everything else, it's where's the business case?
Yeah, with off-highway, quite often the machines are, you could battery electric them, and we've got some projects like that, but in a lot of other instances you can't, because you'd need 500 kilowatt hour battery for a single shift on a 45 ton excavator. So that's your use case right there for fuel cells. The other interesting thing on off-highway, which is a massive challenge, is you're often building something. So you get to site and you're going to build something. There's nothing there by the nature of what you're doing, including a power supply. Yeah,
if you're doing groundworks, the power's not in yet.
Yeah. So how do you do that? How would you have the power supply to feed the electric machines on the site? So there's some interesting issues there around off-highway machinery with the big stuff, but then also with the availability of power on a new project, on a new build. So
it's working then. So that it's getting obviously the availability of the machines and the capex of the machines, and then that hydrogen supply logistics. So that by their nature, construction sites move a lot. Yeah. So what we're typically looking at is back to base fleets right now. So if you look at particularly Germany, they've gone kind of hell for leather, building refueling stations across the country. They've built this refueler network, and you've got refuelers supporting very few vehicles, and it causes all kinds of problems. Whether it's political, why do we spend this money on this filling station that doesn't get used? Or practical, I've got a filling station that hardly runs, so the OPEX is really high with no revenue, or in fact they're failing because they're not getting used enough. So that was one approach. Generally, we look at back to base because it's better economics. A train is the ultimate back to base in some sense. Or a branch line train in particular.
Always comes home.
Yeah, always come home. Although, of course, once you get into the details, you realise that's not always true.
Yeah.
That thing that you think until you really get into the belly of an industry.
Talk about captive fleets. One of the applications that I've seen, which is I've not seen in Europe, but in the US, you've got Nuvera, the Hyster-Yale guys. They doing fuel cells for fork trucks, which that was a real surprise for me that's a viable business case.
Well, the ultimate captive fleet.
Right.
And that's one that's really worked. And I think it's starting to. The original business case for that was places running 3 shifts.
Yeah.
So you've got electric forklifts, and you've either got charging or typically you've got a battery exchange station.
Yeah.
And so the kind of space and actually the safety associated, bizarrely, batteries, lead acid batteries, hydrogen release. So there was a whole lot of cost associated with running electric forklifts, and then there was the kind of loss of power through shift.
Yeah.
And so the business case emerged quite strongly in it for doing hydrogen fuel cell forklifts. And then moving into Europe, we typically don't run 3 shifts in Europe.
Yeah.
Although it's changing, with everybody wanting their things delivered now.
The mega warehouses,
that's starting to pick up. But that's a well-established, lots of units market.
Wow, excellent. So just looking at the time, we've massively gone over, but it's been fascinating conversation, Ben. Thank you. So all the best for the future with Arcola. I'm sure we're going to be talking again very soon.
I believe we will.
Yeah. So great. Thank you. Thanks for joining us today.
Pleasure. Thank you.
Okay. Okay, so that's all we've got time for today. I really hope you enjoyed that discussion with Ben. We could have gone on all day. That's how these things go. Unfortunately, we ran out of time, completely blew the time budget for this podcast. So we've gone massively over what we planned to do, but that's how it is. Ben's a fascinating chap, and I'm sure we'll be talking to him again very soon. So we're going to be doing more podcasts like this using the videos. So make sure you head across to our YouTube channel, check out the video content over there. We've got also some really interesting videos coming soon, which won't really make good podcasts. We're not going to put them as podcasts, but they will be videos coming on our YouTube channel. So really hope you enjoyed today's show. Don't forget to leave us a comment below, give us a rating, subscribe if you haven't subscribed already. Tell as many people about this podcast as you can. Trying to bring as much technical information about electric, hybrid, and obviously fuel cell vehicles to the marketplace, so people get to understand them more and how they work and what's going on there. Okay, that's all from me today. I really look forward to talking to you again soon.